So you're going to be looking for an option where every single one of the listed things have at least what? 2 different atoms, like carbon dioxide, like water, right? Which is different from oxygen gas or nitrogen gas, which are all O2 or N2 or H2. If it's the same atom twice, it's a pure substance, right? I know there's a question about that one there, so make sure you review that concept. Yeah, you recommend? We're doing a review session for the day? Alright, so again, there is a question, I'm pretty sure, about compounds. Make sure you study that. There is a question, I'm pretty sure, about what are the most common elements of life. So remember chunks. Got it? The carbon, hydrogen, oxygen, nitrogen, phosphate, and sulfur. Okay? The most common elements of life. I believe there's a question about that there, so make sure you write that down as well. Okay, keep going. There won't be a question about the charge of the cloud and the charge of the nucleus, although that's probably something you need to know. So you can rule that part out. I don't think there's any questions about that. But you do need to understand that an atom that has more protons than neutrons should have what charge? And what is that called? When an atom has an unstable distribution of charge. You need to be sitting down in the field. What? An ion. But what specific kind of ion has positive charges? It's called cation. Remember I told you that? And an ion with negative charge is called an anion. Know the difference between an anion and a cation. Right? That is going to be the test. Make sure you know that one too. Alright, let's keep going here. So, although you don't need to know the charge of the cloud, you need to understand that if you have more protons than electrons, you're going to be a cation. If you have more electrons than protons, you're going to be an anion. If you're here, you're going to be sitting down. Until there's no chairs left. Alright. Also, you need to understand that atomic mass. What is atomic mass? How do you calculate atomic mass? That's right. Protons plus neutrons is how you calculate atomic mass. Right? Also, you need to understand that isotopes have the same what? Number of what? Everybody, come on. Isotopes are the same number of
neutrons.
Protons, but different numbers of
neutrons.
So they're, are everybody clear on that? Yes. Okay, so make sure you cover that. Different, and if you have extra proton neutrons, what happens? You are
either splits
or ejects them little by little. That's called radioactive, right? Isotopes. We talked about that. Also, what part of the atom gives the element its physical properties?
Proton.
Okay, see? I'm sorry to use Maryland as an example, but all of you need to be at this level. Okay? You need to be memorizing key terms very well so you can learn them. Alright? You need to be memorizing key terms very well so you can learn them. Alright? That is a great idea. You should always bring it to class and always do that. Because then you can always record those on the board and have them to study it later.
I did one day.
Alright, so you should do that from now on. Alright? If you have technology, bring it. Bring it on. Right? So, one more. So we talked about neutrons already. Electron. What gives the element its chemical properties? Neutron. Not the electrons here. The valence electrons. The outside shell. Now, there is a question about this in the test. It basically asks you this. It's a tough question, but it will ask you this. Here's an element. Phosphorus. Find me another element from the list which has the same chemical properties as phosphorus. How would you answer that? Well, you would look at the periodic table, alright? And basically, alright, look at this. Phosphorus is in the 6th column. In that column you have nitrogen, arsenic, and a bunch of other things. Someone that has the same physical properties chemical properties as phosphorus will have the same number of valence electrons as phosphorus. So you've got to find out someone in the same column as phosphorus. Also, you need to understand that. It's an important concept. Columns means valence. Rows means the number of valence. So the more rows you have, the bigger the atom gets. And the more column, at the column you can see how many electrons in that last row. So if I am in the 3rd row, how many valence shells do I have? 3. And if I'm in the 4th column, how many valence electrons do I have? 4. The columns tell you the valence number, and the rows tell you how many valence shells. You got it? I believe there is a question like that tells you phosphorus. By the way, the question is tricky because it doesn't give a periodic table. Basically, this is how the question works. It says phosphorus has an atomic number of 15. Okay? So it says phosphorus has an atomic number of 15. Okay? And then you have other elements. Nitrogen with atomic number 7, oxygen with atomic number 8, carbon with atomic number 6, and so forth. And then sulfur with atomic number of 16. And they put all these things there, and they will ask you, which of these options have the same chemical properties as phosphorus? So how would I answer that question? Well, I would have to find out what phosphorus looks like. So I have 15, right? So I would have to do the nucleus, 1, 2, right? Then that's the first level, right? The second level. So the second level, we'll put 1, 2, 3, 4, 5, 6, 7, 8. Full. I'm down to 10 electrons already, right? Which means on the last shell, I'll put 1, 2, 3, 4, 5. Right? I have to find an element that's similar to that. That has 3 electrons on the last shell. So let's see. Nitrogen. 1, 2. 1, 2. So let me erase this stuff. Just put nitrogen in the middle now. Nitrogen. 1, 2. 1, 2, 3, 4, 5, 6. So it's 7 total, right? So 1, 2, 3, 4, 5, 6, 7. Last shell of nitrogen, how many on the outside? 1, 2, 3, 4, 5. Wasn't that the same thing as phosphorus? So even without a periodic table, you can tell that. But if the test gives you a periodic table, you can just use a periodic table instead. Alright? So there's a question like that. Also, there might be a question or two like that basically say this. Carbon has 4 unpaired electrons. How many bonds can carbon make? 4, right? Nitrogen has 3 unpaired electrons. How many bonds can it make? 3. So basically just look at how many bonds to relate to electrons it has. Also, it might be a question here. There is an element that's on the left side of the periodic table. Is it going to give up electrons or take electrons? Think about it that way. If he's on the left side, he probably has 1 or 2 electrons on the outside. So it's easier for him to get rid of those 1 and 2 than to get 6 more. So he's going to be giving them away. That's what makes them a metal. Remember that. Yes. I don't have time to talk to whatever. Okay. The drawing is Friday. It's on the website. We're doing a review. Can you wait until the review to ask questions? Because people have to leave. Alright. It's anatomy. The first drawings of the Friday for the anatomy project. That's what she was asking. Okay? Alright. I told you that was going to be a question about compounds. Make sure you understand that. Let's see what else. Also, why do atoms bond? Yes? To be complete on the outside. Which means who doesn't bond? Complete ones. Who are those? Noble gases. Okay, good. Make sure you know that. Okay? What do you call attractions between molecules? That's a question. I know that. There's a question that has that in the options. An attraction between molecules, not within molecules. First of all, what's the strongest bond? Followed by a polar covalent bond. This is a question, I know that, remember this. When does a polar covalent bond happen?
When one gets more energy than
One gets more electrons than the other, which means one of the atoms in the bond is hungrier for electrons than the other. For example, you have oxygen versus hydrogen. So it gets polarized towards the oxygen. So whenever you have a bond between something that's very electronegative, wants electrons a lot, and something that doesn't want it a lot, you're going to end up getting a polar bond. That is the question. So basically, it's going to ask you something like, why does water have covalent bonds or something like that, and polar covalent bonds, and you say, oh, because oxygen is a lot more electronegative than hydrogen, right? So that makes the oxygen end negative compared to the positive end of hydrogen, all right? By the way, the intermolecular forces are called van der Waals forces, right? But what is a special type of van der Waals force that happens in water? A special type of bond between the water molecules. Yes? 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 Hydrogen bonds. Very good. Gotta know what gives water its properties. Hydrogen bonds. Right? Okay, good. Let's move on to metabolism, because we have a lot to cover still. So metabolism is heavy in this test. We've got a lot of metabolism questions. Let me give you some examples. One question, I think, actually a series of